All right. So, good morning, everyone. My name is Edgaras. I work as a site reliability engineer at Vinted. And for those who doesn't know what Vinted is, it's a second-hand fashion marketplace. And Vinted's goal is to actually increase the sustainability throughout the world. So today I'm going to talk about the increased velocity of code deployments with Kubernetes, GitOps and Canary deployments. But why do we actually care about the faster deployments? Well, for us, faster deployments is that you can ship features faster, right? The more features you have, the more end users you attract, right? And the more users you attract, the more users are using your platform, and therefore, everything increases the sustainability. So in this talk, I'll cover the journey of our cloud-native selector tools, how we actually managed to do that. But before that, let's take a sneak peek into Vinted's infrastructure of what we currently have with all of our production Kubernetes clusters. So at the moment, all of our stateless services are running on Kubernetes. So that's except the databases and other stateful services. All our production Kubernetes clusters are running more than 20,000 Kubernetes pods. And those pods are running on more than 700 physical machines. So yeah, that's right, we're using physical infrastructure in our physically co-hosted data centers. But for us, the most important stat is this. Accumulating all of our production Kubernetes clusters and all of our services that are running in Kubernetes clusters, we managed to do almost 2,000 deployments per day to production. 2,000 deployments per day to production. I mean, the number is so big that we had to double check and triple check the metrics if everything's like in place. So yeah, that's a big number. So how we did end up there? Let's start what we have done before Kubernetes. Vinted is a Ruby monolithic application, right? We also manage our infrastructure as a code with Chef that's also written in Ruby. So at that time, for us, it made sense to use a tool called Capistrano, which is also written in Ruby, and you can write your orchestrations in Ruby. So in a nutshell, what we did, we actually wrote a custom code that gathered our physical servers list from HashiCorp's console service discovery, and the Capistrano tool knew where to deploy our code. When the code changes and is being merged into the main branch, to ship the code to production, we used chatbots for that and to execute a rollout command. Who else in their organizations are using chatbots? No, okay, a few, okay, cool. So later in other slides, you'll see that chatbots is actually at the heart of Vinted operations. Right, so as Vinted is growing rapidly fast, we bought more and more physical servers. It didn't become that scalable at some point. And we also had some pain points, like we had services isolation issues. You know, on one physical machine, there are several physical servers running. How do you distribute the resources between them? We had physical servers with different CPUs. So it means that on our load balancer layer, we had to write a custom Chef code that actually calculates the clock speed of CPUs of our physical servers, the amount of CPUs it has, and write a custom weight for that backend. Of course, Ruby dependency issues, because as I mentioned before, several services running on the same server using the same dependency. What if you want to bump that dependency? It took some time to do tests across different services with that custom dependency. And with all of that, we had to also write our custom in-house solution for configuration management and secrets management. So at some point, we thought about jumping onto the Kubernetes hype train, because everyone's doing it, and it's popular, and why not? So we still have our own physical infrastructure, physical servers, and we started with architecturing our Kubernetes clusters. We have 3 data centers in Vilnius that are close to each other. We have low latency in between them. So for us, it made sense to have a stretched one physical, logical Kubernetes cluster across those 3 data centers. So it saved us resources. We don't need to duplicate our applications in each data center, because if one data center goes down, the pods are going to be rescheduled on the physical nodes that are in different data centers. With this setup, we're running our control plane on virtual machines separately from Kubernetes clusters. We're running a CD cluster as well on virtual machines. And at some point, when our number of pods grew and deployments increased, we started sharding a CD cluster, and we have separate CD cluster just for the event endpoint. Probably the hardest part was thinking how to integrate Kubernetes networking with our data center's internal network. As you may know, Kubernetes has a first-class citizen support to public clouds. You want to expose your service, public cloud creates a load balancer for you automatically, does the routing and so on out of the box. So what we came up with, actually, we did a BGP peering of every Kubernetes physical node with top-of-the-rack switch. So in that case, we advertised Kubernetes services IPs and Kubernetes pod IPs. So those are reachable outside Kubernetes cluster in our internal data center network. And that has proven us in the long run because, for example, Reddit had a similar approach to Kubernetes on physical machines. But what they did, they had BGP reflectors only on control plane nodes, and when they had issues with control plane, all of their Kubernetes services were disintegrated, and they had outage for 5 hours. So we have a much more higher availability because we're peering with top-of-the-rack switches of all of the Kubernetes nodes. So we have Kubernetes, and what's next? We can redo the deployments to be them faster, right? So we want to automate deployments. So we thought of using GitOps workflows. So who knows what's GitOps? Okay, so for those who doesn't know, GitOps is a set of DevOps practices around CI/CD workflow, blah, blah, blah. But actually what it is, it's your infrastructure as a code stored in Git repository that's being synced to your production clusters. And this is a typical GitOps workflow and what we're using at Vinted. So there's 2 separate systems for continuous integration and continuous delivery. And for continuous integration, system works only with separate code repositories. And for continuous deployment, system works only with Kubernetes deployments manifests monorepo. So all of the deployments are in one monorepo. So just to jump through, when the code changes in code repository, our CI system picks it up, builds the code into the container, runs some tests, does some security scans, pushes to container registry, and after that, clones the deployment's manifests monorepo and updates the image tag of the recently built container image and pushes to the deployment's manifests monorepo. Then, continuous deployment tool that we're using, Argo CD, also from the Cloud Native Foundation, actually monitors the changes of that monorepo. When it detects changes, it clones the repository, finds what changes, and applies those changes to Kubernetes cluster automatically. So at this part, we're not using any of the chatbots. And this is an example of our deployed application, how it looks like in Argo CD user interface. So with that, as I mentioned before, we have this huge core monolithic application that's written in Ruby. So we managed to squeeze that Ruby application deployment duration to around 20 minutes. That's pretty slow, you might think, but that includes actually database schema migrations, the core deployment itself, and it also has 3 separate services as a dependencies that also has to be deployed, like Kafka consumers, sidekicks, and so on. So when the deployment duration is around 20 minutes, deployments to production happens every 20 to 30 minutes, every day. It's fine while the code is working, but sometimes bad code happens. Tests are not covering it. So what do we do with rollbacks? As I mentioned before, chatbots in the heart of Vinted's operations. So we wrote a chatbot to automatically stop synchronization between Kubernetes production clusters. Then we find the last known good container image tag that doesn't have any bugs. We apply that image tag. And when the bug is fixed, what we do is we automatically enable synchronization back on. That was fine, but that doesn't scale well, We have a lot of developers, and bad code might happen more often than you think of it. So the next step for us to increase the velocity of deployments and to have automated rollbacks was introducing the Canary deployments. And who knows what's Canary deployments? Raise your hands. Okay, quite a few. So who doesn't know? Canary deployments is when you have your current version of software, of application, and you deploy a new version of application. And start gradually switching some portion of traffic to the new version of application, like 10%, 20%, do some tests down there, if everything's okay, and switch traffic 100% to the new version. So for that, we chose another cloud-native foundation tool. It's called Argo Rollouts, and as you can guess, Argo, it integrates nicely with Argo CD, right? So what Argo Rollouts does, it has deployment strategies for Canary and Blue-Green. It also can have analysis of the Datadog metrics and Prometheus. So here's an example of how we're doing analysis using our internal Prometheus instance, and we're querying HTTP errors metric. And this is an example of how our core monolithic application Canary looks like. So at first, when the new version is released, we're switching for 40% of the traffic, doing some analysis. If everything's okay, we're setting the weight of traffic to 60%. If everything's okay, after the analysis, then the traffic is fully switched on. And other rollouts are kicking in. But what about automated rollbacks? Are they working? So as you can see from this slide, yes, they're working automatically. So at first, you can see that when new version was deployed, the old version didn't scale down totally, because analysis picked up that there were increased HTTP errors, and the older version actually was scaled back up. And when the new version of the code has been released with the bug fix, everything went fine, and other releases kicked in. So this core monolithic approach, we do today, at this day, 30 deployments per day. Average duration is 20 minutes per deployment. As I mentioned before, database schema migrations, few of the dependencies are deployed along the way. Core is running on 1,000 pods during non-peak hours, and it auto-scales up to 2,000 pods. And our core application handles around 170,000 requests per second during the peak time. But talking about all of our production clusters and all of the services that are running there, we managed to do almost 2,000 deployments per day, and average deployment duration is 30 seconds. And that's around 20,000 pods and 650 services. So just to recap what we had before and what we have now. Before, we had physical servers that were kind of difficult to manage from the isolation perspective and dependencies. And now just Kubernetes takes care of everything. And before, we had semi-automated deployments using chatbots. And now we switched to GitOps with automated workflows. And of course, we added one more additional step. It's to fully roll back deployments in case of something bad happens with Canary deployments. So our journey didn't end up here with 2,000 deployments per day, sorry. But we're always looking into ways of extend our performance. So as I mentioned before, we're running only stateless applications inside our Kubernetes. So we're looking into ways of introducing databases and other stateful applications to our Kubernetes clusters. We're looking into service mesh solutions that we're trying to work on to have a better routing capabilities, automated MTLS encryption between the services. And yeah. And that's it from me. Thank you.
Folks, I think we probably have time for one question. Do we have any questions?
Everything's clear?
Everything, oh, we got one, there we go. Have you seen those microphones you get that you can throw? It's like a big softball with a mic in the top and you just throw it across the room. We'll get one of those for next year.
Hello. So we saw that you use Canary analysis for health monitoring. Do you use additional tools to gather metrics?
Yeah, so actually what we're doing at the moment is we're gathering metrics from our application with Prometheus, scraping metrics, right? And as I mentioned before, we're looking into service mesh solution that automatically checks the traffic of the failures and can easily integrate with Argo rollouts.